Welcome to Math 2318, Section 2.2. In this section, we are looking for the inverse of a matrix. So given matrix A here, we'd like to find a matrix called A inverse, where if I multiply it by A, I get the identity. So one way to see if we can find this inverse is to put our matrix A in the front, put the identity matrix on the right hand side, and now do row operations until we get the identity on the left. Alright, so I first took row 2, moved it to row 1, and now I used the 2 to make a 0 where the 7 was. I didn't try to divide by 2 and make fractions everywhere. I decided to wait and save that till later. At that point, I divided row 1 by 2. I divided row 2 by negative 18. At that point, I'm taking the 1 and making a 0 above it. And by doing that, here I have the identity on the left now, and the resulting matrix on the right is A inverse. The matrix that when I multiply it by A, I would get the identity. Alright, in question 2, we have a similar problem. We have matrix A, and here's the identity. So we're going to go the same way. Now I don't see where I can divide anything cleanly. So I'm just going to go ahead and use the 7 to get rid of the minus 3. So I actually did that by 7 times 3 is 21. And minus 3 times 7 is a minus 21. So when I add them up, I do get a 0. Alright, and so when I do that, I get the following. I divide row 2 by minus 1. Alright. Once I've got the minus 1, I'm going to get rid of the 16. Still leaving the 7 to the last possible moment. And now I can divide row 1 by 7. And we do get the identity. We get A inverse on this part. And what I notice is A inverse. They are one and the same. So A squared is essentially the identity. Alright, in question 3, we're going to use A inverse to solve something. So if we have a system of equations AX equals B, then multiplying on the left both sides by A inverse, well, A inverse A is the identity, so I get X, the solution to the system. And X is A inverse times B. Alright, so X is A inverse, so here's A inverse multiplied by B. Sizes are correct, 2 by 2, 2 by 1. So my answer is 2 by 1. And so performing the multiplication 1 times 4, 1 times minus 2, we get a 2 and a minus 5. Alright, in question 4, we want to solve the equation AB equals BC. I want to solve this for A, assuming that A, B, and C are all square of the same size, so multiplication makes some sense, and B is invertible. So since there is a B is invertible, there is a B inverse. And so take what they gave us, and now I'm going to multiply on the right by B inverse? Well, B times B inverse is the identity, so I get matrix A, and multiplying this on the right hand side by B inverse, we get that A is B times C times B inverse. Question 5 is a bit of theory, and that is explain why the columns of a square matrix A span the entire space when A is invertible. Well, the secret is, since A is invertible, everything in B, there is a unique solution. There is an X where AX equals B. And so what that means is, anytime I have a B, there is an X. And so this particular mapping or transformation T is onto, and so the columns will span the entire space. All right. Question 6, we have a 3 by 3 matrix. We're looking to find A inverse. All right, so, well, here's matrix A on the left. On this portion, we have I3. And so I'm going to do row operations until I get the identity on the left. Alright, I have a 1. I can use the 1 to make some zeros. So did that. I have a 1 in this position. I already have a 0 above it. Make a 0 under it. Alright. So all that there is left to do once I've done that is, well, I could divide this by a negative 10. That's going to make some ugly fractions. Why don't I just use the minus 10 and the minus 2 and make a 0 there? Once I make the 0 there, then in that case, I can go ahead and divide by minus 10 all the way through. So dividing by minus 10. And on the top one, I'm going to divide by minus 5. And so what I get now is A inverse, and that's the matrix that would undo what matrix A did, or A times A inverse is the identity.